Hi, I'm Doug Bailey from Power Integrations. PI is the leader in energy efficiency and integration for small power supplies. I'm going to walk you through an example. Here's an example of a power supply that's been built using discrete components. What you'll notice immediately is the large number of components on the power supply. Each one of those has to be independently designed, specified, sourced, and made available to manufacturing, and takes up space on the board. I've highlighted the external switch, the GAN and the driver device. That's the main high voltage power switch that's responsible for executing the switch mode power supply function that ultimately transmits the energy across the transformer. I've just highlighted the external current sensing. That circuitry requires interface logic, amplifiers, and design. It also tends to limit the dynamic range of the power supply in both voltage and current. Another thing worth taking a look at is the amount of bias circuitry that's required. This is because the power supply itself needs to operate over a wide dynamic range, and that means the power supply for the controller chip needs to be conditioned within the acceptable limits of the controller. That brings us to the primary controller. That's a relatively simple device, and it interfaces into an optocoupler that provides feedback from the secondary to the primary and permits regulation. The other thing that's worth noticing on the primary side of this power supply is that there's some mitigation required in the power path to reduce the EMI, and that is an unfortunate additional component. Not only does it have cost, but it also has consequences to the operation of the power supply and the efficiency of the power supply. Moving over to the secondary side of the controller, past the opto and past the transformer, we get to the synchronous rectifier. This is a high-side synchronous rectifier. It's quite complicated. There are several components there. Once again, all of those components need to be specified, designed in, and proven to operate across the wide range that we expect this power supply to function over. This power supply is a USB PD power supply, and so it includes a USB PD controller device that's also separately sourced, separately biased, and requires a large number of external components to operate. Power Integrations is the leader in integration, and absolutely we can do better than this. Let's take a look at how all of these components fold down into an InnoSwitch. In some cases, we've eliminated them altogether. In other cases, we've integrated them. But the overall effect is a gross simplification of the power supply in order to generate a more efficient, more effective, lower cost, and higher reliability product. All you need to do is switch to an InnoSwitch PD. The InnoSwitch device incorporates the sense, the EMI, the primary controller, a vast number of discrete components, and the isolated feedback. That isolated feedback is critical. We call it flux link, and it's more than just a replacement for an optocoupler. The flux link is faster, it's more precise, and it allows us to do a much better job of controlling the primary switch and the synchronous rectifier in a way that works across a very broad dynamic range and allows the product to be more reliable, more effective, and more efficient. And then finally, the component count. We've moved from 101 components down to just 45. That's the power of integration.